build progress on my little project I'm working on here. So this is going to be a multi-purpose power supply for some little science experiments I have in mind. There's a 20 amp variac here, Chinese supplied, and then I've got a power switch here for turn it on and off. Got a DC activate switch to turn on my DC section of this power supply. There'll be a DC panel meter mounted either here or here. I'm not really sure yet, but it hasn't came in from eBay. I got nice new old stock voltmeter, used old voltmeter of amps. It's got a little bit of dirt on it I want to clean up later. But nice little Bakelite looking panels. Beautiful Simpson movements. And then on the back side here, nothing but the highest quality Chinesium variac. Just kind of, I took the whole front section of it off and just clip the wires, and I'll splice all it in. I'm going to keep the external cage on it though, because it protects the deal. It's nice to unmount this. I just take the handle off and then undo the 4 screws around the base, and the whole thing will just fall out. Actually ended up being very maintainable. And so I'm going to have this, and then this is the back of the enclosure, and I've got these big freaking Mallory caps I picked up in an estate sale from a ham radio guy years ago, and they're 14 microfarad at 350 volt DC. So max surge 400 volt DC. So what I plan to do is I'm going to have the output of these 50 amp Chinesium rectifiers from Bojack, which is definitely a trustworthy brand, going through these. And so what I'm going to do is I'm going to mount these through the back of, this case it's a cool lid thing, but it'll mount through here, and I'll mount the rectifiers probably up here, and I'll have holes, and there'll be heat sinks mounted on the outside. So it'll conduct heat through this chassis, through thermal paste, into the heat sinks on the back side. So this entire thing can be a giant heat sink. As I'm saying that, maybe it's a bad idea to do that with the caps. Maybe I find a way to mount the heat sinks somewhere else. Maybe put them on top. It would look cool. Like a hat. Little tiny heat. I don't know. I'll figure something out. Either way, this is nice because I can do it here for maintenance. But I'm going to use some copper strip. Has a high current bus on these. And I plan on putting a 12 volt, some sort of like maybe car battery terminals on the side here. And then I'm going to have a outlet of some sort. I think I might use some machine screws and like a stud mount like this to mount 120 volt, just regular AC outlet right here, because this is only 20 amps AC. So basically though, these rectifiers, however many I so choose to use, I don't know, these are supposedly 50 amp. The spec sheet I'm looking at says like 450 amp non-repetitive peak forward current for single half sine wave superimposed JDEC standard. This data sheet here. I don't know how well these Chinese knockoffs are going to survive that. So I think if I did more than one in parallel, which generally you don't want to do with rectifiers without like matching resistors or something. But anyway, I'm gonna play with this, and then I've got a ton of inductors from another estate sale I picked up. A ton of these, and I've got the RF data on those guys. And so I think I'm going to use those inductors to basically post-tank circuit. I'll have, the positive and negative leads will wind around together around the inductor. Common mode choke. It's a common mode choke coming off the DC power supply to the output. So it'll go from rectifier to capacitor bank to common mode choke and then out. Should be a very stable linear power supply with a variable AC input. So I can crank this thing up to 130 volts AC in, and I can put out some losses, but let's pretend 130 volts DC out, which will be cool. Anyhow, so it seems like this would be a huge bank I could do a lot with, really, really low ripple based on the math I've done. Cool linear power supply, and I wanted to use this with some magnetics experiments I'm looking forward to doing. So like I want to do some stuff with magnetizing, demagnetizing. This isn't big enough for a coil gun or a coin crusher or something like that. It's not a high enough voltage, not a big enough cap bank, but it is a really cool, stable, linear DC power supply that can put out some nice current. How well it will live is another question, but these components are all relatively cheap and findable. Mounting those caps, I got to figure out what I'm going to do. I'm considering putting something in the middle here and tapping in the bottom and having something like that pulls down on the cans, like in between each set, or maybe I like put a strip here or something that goes to the bottom here and then to there, and I 3D print something. I'm not really wanting to put PLA in here. I'd like it to be all metal. So if it catches fire, it's in a metal box Metal, who cares? You know, magic factory smoke can come out and I don't care. Most of these components would survive a fire inside this thing. Or the capacitors letting loose their smoke. They do have vent valves on them right here. I mean, hopefully they never pop because I'm sure it would smell like absolute crap. But yeah, anyhow, this is the weird power supply thing. I've got to say, though, I love how this looks right now. I really want to get that DC panel meter mounted in here below. Like, because I think it's going to balance out really nice. You got these two AC meters. There'll be a DC meter right below. I didn't solve in the circuit for, like, if I had this turned up at 130 and I just flip the switch on to turn on the DC side of the circuit, it's going to try to dump at 130 volts into that capacitor bank, which could be a lot of inrush current, and I don't know how well they would handle those. So what I might have to do, I have a couple options, but either way, I'm just going to put a note here for now, because it's me running this, that, like, you know, hey, start at 0, so I'll turn on AC power, turn on DC bank, and then slowly bring the power up, and I can actually watch the current draw, you know, on the AC side, charging at the bank. I honestly don't think it'll take that long with that bank to charge through those, but I don't want to just, like, you know, turn this thing all the way up to 40 and then you like, bam, you know, and it's trying to charge the cap bank at, you know, 40 volts through those things instantly, because the input will happily shove 20 amps towards those little Bojack rectifiers. Anyhow, oh, I also have these, also from random estate sale stuff I whipped out when I was finding those cans. I have a ton of these resistors of varying values. So I'm thinking I might use one of these as like a surge protection, but well, we'll see. Or I could use it to drain. Maybe I put a high current switch in here as like a bank drain or something I can flip. I don't know. Figure it out. It's cool. Having fun with it. All right, so we got it mostly wired up. I'm going to do a function test. We're going to see if I'm going to make this thing catch fire or work. So I've got a power lead temporarily hooked into my terminal block here. I don't have any of the switches hooked up yet, but I do have the voltmeter and the amp meter hooked up. So we're going through the amp meter, which I think this is a direct model. I don't think I have to use a current transformer on this. We're going to find out. I'm going to click it off really quick. And I've got a space heater hooked here, and this is connected to a variac. So we're going to slowly increase the voltage with the space heater running just a fan. And then as long as the amp meter doesn't, you know, in which case it needs a CT, we'll know that we can give it some more power, and I'll start testing. I can go up to 5 amp with the variac I'm testing with. This one's rated for 20. So the one feeding this is my smaller little baby, non-isolated one you've seen in other videos, which is this little milk house heater to fan. Oh, that was already on heat. Fan. Okay. All right. Click this on. It's just all the way at 0. And then we're going to start increasing power. I didn't plug it in. It would help if I plugged this in. All right. Let's turn on the power. And as I turn this up, we'll watch the current. That's good. Turn it all the way up because we're going through a variac on the other side. Okay. All right, and I'm watching the variac down below to make sure we don't overdo the current. Turn this up here. And we hear the fan. I don't want to go much over. Ooh, let's not overvolt the fan, yeah? But that's good. That's good. All right, let's bring this back down. Bring it back down. Nice. All right, let's go adjust that and turn the heater on. We're just going to crank this up to 1,500 watt. There's no way we'll get that close because, again, the variac here on bottom, that's 5 amp max, so we're not gonna blow that out. But I'm watching the current meter here on the side of this one. Also Simpson meters. You tell me I have a thing for Simpson meters? Let's try this again. I hope you enjoy Figment peaking right there. Anyhow, let's see if we just bring this up. And we gotta watch out because, again, I got 5 amp max draw on the one below. 3, 4. Nice. Nice. Okay, so that is not entirely accurate at the bottom of the scale. I've got that about 5 amps on my side, but I don't want to push that little tiny variac too far. So I'm going to connect this one straight to wall power, and we're going to see if we can run the space heater on it. Okay, let's give this thing a bit more juice now. See what happens. Wow. That is awesome. I can feel a hum on the windings of this freaking variac. That is wild. This thing is doing great. Okay, and it is passing through the current meter. So I'm going to let this run for a bit and check my wiring for hot spots on the backside. Obviously after we power it down and unplug it. But we'll do this to kind of do a quick current check on it and make sure everything's happy. Very slick. And again, eventually we have a thermal fuse here. It's not wired up yet. It'll be a 20 amp thermal. Main power on off. And this is going to power up that DC system. And eventually when I get the other meter, and I'm going to either mount it here or here. And it's a horizontal mount meter. I know I'm at this thing laying on its side right now, but you can kind of imagine a little DC voltmeter here, and then I can flip this up and engage the DC, and I'll have some binding posts, some high current binding posts on the side for future experiments with magnetics and stuff. So yeah, pretty cool. Didn't get video of this particular section, unfortunately, due to a camera issue, but I was able to connect that DC load bank pictured here on the right to the power supply, and I just had some leads on channel 1 and channel 2, both connected to the capacitor bank. And I was running this thing up and checking it out and kind of putting a load on it. I had it about 75 volts DC at about 4 amps per channel when one of the channels went into thermal overload. And because the power supply is unregulated, the voltage jumped on the other channel that was still connected. And I got some carnage to show you. Well, the massive DC unregulated power supply I have claims its first victim. This is my programmable little DC resistive or programmable load here, and it was running fine. I had both channels connected on it, and I had it loaded down about 4 amps on each leg, about 60 volts. You know, pulling some good current. And one of the legs went into overcurrent protection, and when that did, the power supply is unregulated. Voltage went whoop, and as the voltage went up to, I saw 90 on the display, and then I heard pop. And sparks shot out, and it smelled like the holy smoke came out. I flipped off the DC power as fast as I could, but I don't know if you can see. Here, let me zoom in here. I'll lay this down underneath the lamp. There is a leg that was blown away. You can actually see where the how many amps DC this thing can put out. Like, it's technically on paper it's over 100 amps DC at whatever voltage I'm selecting. But yeah, it blew that thing out. So yeah, unregulated power supply claims its first victim. It's not, the intent is for powering magnets and such, but anyhow, I've ordered a new component of Chinesium quality. I'm not going to Mauser for this. This is a Chinese load bank. It's going to get a Chinese part to replace it, but yeah, so I'll replace that, and then it's the first victim of this thing. I'll show what it looks like on the inside. All right, here's the inside of the power supply. I've got the cord hanging right here in case somebody's going to ask watching the video, but leave this back down to 0. So I've got the variac here. Underneath, there's a terminal block. Everything on the front panel is mounted on a terminal block way down in there. So you got to take this front cover off to get to anything on this anyway. So put the terminal block down there. Up here, all these wires, the ground is special. It gets to hang out by itself, but all these wires are current carrying. And those go to this. Now this is where all the incoming power and the rest of the chassis is terminated to the front panel. So everything from front panel to chassis terminates here. On the chassis side, we've got a cool setup with 2 rectifiers running in parallel. I have not done this before, but some great Googling and checking forum posts. So I've got both hot legs on the AC input for this guy, and then both neutrals on the AC input for that one. And then the DC side is hooked up in parallel. So you've got DC positive on each leg, positive, and then DC negative. They seem to share load really well. But yeah, this barely gets warm with the current I was drawing. And the interesting thing is I did add a little tiny, I had some safety caps. I put a little tiny one in there. It did reduce the hum quite a bit on the windings. This massive cap bank. So right now I've got the main high power leads taped off. You can see when I was first powering it up, I tested it, just tapped it to itself at like 2 volts, and I was like, ooh, okay, she sparks, it's good. I'm going to cut a hole for the bulkhead for power output probably back here, and then those cables will land there. I'm also considering landing the DC bulkhead on the side, but I'd like it to be away from the user at the current it's pushing, so I think I'll have it on the back side. That way your controls are here, and if something nefarious happens with the current on the cables, it's behind the giant chunk of metal. I've considered putting, I've got these big military surplus resistors I think I showed earlier on, and they seem to be most of the stuff on eBay because I don't have any docs on this and I can't find anything. It's a Mimcore 8035s, and I think these are like 30 ohm or 25 ohm, and most of the stuff that looks like this says 500 watt handling capability. It is heavy, it is ceramic, and these are drilled through. This is interesting. So I've got thermal transfer paste on this. So this rectifier going to the heatsink has thermal transfer, and then I ground off the powder coat on the chassis here, and I put thermal transfer paste, just CPU paste. So it's like that expensive silver paste on it. And then on the back side, I ground, same deal, sorry to make you dizzy here. I ground off the powder coat underneath these, and I did the same thing where I put the silver thermal conductive gel underneath each one of these. And I thought the brass gave it a nice look, so I stuck with a brass nut there. I thought that looked really cool on the back side. I've got this nut in here. Probably wouldn't have gone with that in hindsight, but I wanted to stay with the brass. I'm like, you know what? It's thermally conductive. I'm just going to go with it. But I don't like how close it is to the leg. So after I'm out of the rectifiers, I kind of bent the legs out a little bit. But if it does short to ground, this chassis has many, many ground points. So incoming, before we even go through this terminal block, this heading down here to the outlet, all of that metal in the outlet for the output for AC is grounded. And it's riveted to the chassis, which is grounded. And then, of course, once it goes to the front panel has multiple connections to the variac as a grounding point, and then also has from the variac and that to some of the meter legs for grounding. And the variac itself is attached with, there's 3 screws underneath this. And I've drilled these 3 screws, and they're attached inside the variac casing as well. So it's got a really good low resistance connectivity to the front panel and the safety ground. But if this chassis does have a ground dump, it's gonna pop the breaker pretty quick. It'll be a good dead short, which is what I want. So if this thing does fault out, it will properly fault out. I really do like this case. I think it's a Bud case. I got this on DigiKey, I'm pretty sure, a while back. I'll have to see if I can find the part number. But I love the folding top is my favorite part. Once it screws shut, it squares everything up real well. But when I'm working on it, I can just, flip this little guy open for inspection, and I can see down in there and kind of check on stuff. I'm glad nothing seemed to be hurt. This thing didn't care that the sparks blew and the freaking power supply detonated over here, but this guy gave 0 flips. Just absolutely was happy, having a good time humming away. So really crazy how powerful this thing is. Was not expecting it to be that much power. So I look forward to building some cool high power DC magnets with this. I haven't really been filming this part, but can we just take a second to admire how beautiful new old stock Simpson gear is? Look at that. Just absolutely beautiful. I mean, that's a beautiful looking meter. And it's got a nice heavy feel to it. I know you can't feel it. There's a face plate for it, this little decor plate, and then there's the bracket that holds it up. And there's 2 holes in the bottom where it'll slide in and lock. And so I've got my template, and of course to put the template, there's C template on the bottom. I put that on the photocopier. Doesn't really resize it too badly. And so this, I think I'm gonna put down here on the volt side. I thought it was gonna be wider, the pictures, but I was like, all right, that's still just fine. So it's gonna go down here somewhere. I'm gonna center punch the slots, and then I'm gonna use I'm going to basically trace with a knife and then use a Sharpie to mark the outline for the thing. And I plan to go in here with the Dremel and basically do a cut with a cutting blade. So I'm going to see how well that works. I also have a nibbler tool I might use. It's a Chinese nibbler tool. I don't know that it's going to work well for something like this. I think it'll be too thick. So we'll find out. I think my hands would also be begging for relief if I tried to use that nibbler, but we'll find out. I might use a nibbler tool. I might use a cutting blade. If I use a cutting blade, I'm going to have to, obviously, no matter what, I think I have to take this front off. But if I use a nibbler, I might not have to take, drawing a hole, it's going to leave. The issue is I got those real fine particles if I drill holes. So, I don't want that inside the transformer. So I'm going to have to unmount this entire thing, unwire it, and then pulled off to do this. Now, thankfully, I don't have to do much because all of these leads feed the Variac. I made it where like everything's in one spot. So all of these basically can be disconnected and the whole front panel can come off. That's the whole reason I've done this junction here, is to keep that somewhat modular, so if I go in here for maintenance, I don't have to like go pull random stuff off when I forget where I've wired things in a year. In addition to that, I got the bulkheads in for the power for 12 volt, some random Amazon dealio, but these guys look nice and beefy. And I think, like I said, I'm going to put these in the back. I was going to put them over here, but I've got all this space, and I might add some contactors in because I have some other ideas for safety and some ballast resistors and things I might add. So I might leave the space above the caps empty and try to shove them in back over here where I have all this, quote-unquote dead space, because the issue is I can't put anything back here with the Variac. This is taken up. There's like, I don't know, was that an inch and a half basically, between the back of the Variac and the back wall, and I've got this space up to here. So I've got enough space I can put the bulkheads in here safely, and I can just reroute this cable from the top that way whenever I redo this. So I'll get some ideas on how I might redo this. We're going to see what ends up happening, what I feel like as I pull it apart. Because this is at an angle and everything lays in at an angle, and because this is a cylinder, going back so far, it's a bit different than if it was just like a box. It'd be like, okay, well, I just know dimensionally this will be this far back, but now it's at an angle. So mentally it's a little hard to like map it out, you don't think about it, but I've measured nothing for this, by the way. This entire thing has been eyeballed, so looks okay for something we just eyeballed, right? All right, anyhow, let's get to work. Okay, so I've got the DC meter, and I need to loosen it and twist it just a little bit, but I've got it offset by just a bit because I wanted some space over here for a contactor, because I want to have I've got those bigger resistors I showed earlier. You see right here, it's completely off, but that's how much power the bank is holding still. Those capacitors are still at 90 volts, so, still arc flash hazard. But we'll go ahead and we'll fire it up so you can see. So I'll turn on DC tank first, make sure this is a 0, and then fire up power. We'll start turning this up. You'll actually see, there we go, start charging the DC bank up. It's interesting, I get to like 120, I can turn it off. If you watch the current meter, when I turn it back on, you'll see it pop for a second. It's not big enough here. I'll do like that. There you go. See, it kind of bounces as it throws power in, but it'll hold stable for quite some time. And those caps are rated for 400 volt working DC. But yeah, it's pretty cool to have that because I actually have an indication of live power in the bank. So everything's happy. Inside, I've done a bit of cable cleanup. So keep in mind, I'm not touching anything right now, and I'm holding the cell phone with one hand, but that's still very much arc flash hazard, so like that would not be good to short. So inside, we've got the DC bulkheads, and I've zip tied everything kind of tightly between the rectifiers. I run back, and I've got my DC cables on the bus bar. I'm not going to hold the phone directly over the bus bar, but then I've got these two sense leads right here. And those two sense leads are unfused, so at some point I need to add a fuse to where they connect, because if one of these was to short to chassis or short to another one, it would just like melt. So there's that. But anyhow, those two sense leads go straight to the voltmeter, and they're kind of off by themselves. And then I've got the AC, all the AC power stuff going through the bulkhead here. So this cable bulkhead is where everything terminates, and so I've kind of got all of the AC cables going through here, and then there's little DC cables traveling, and they go and wind around the Variac. I've got them zip tied to it to go to the bottom, and there's another bulkhead here for all the switches and stuff to tie into, and the Variac, the 3 leads off the Variac. So all this voltmeter, all of this, and the switches go through the little cable bulkhead here, but then this guy just sort of goes straight to the 2 sense leads. But you see, it holds current for quite some time. I have a resistive ballast that I had hooked up to this, and I think I have a video I shot of the first victim here. So I do have a DC load I can hook up to this thing, but it'll drain down eventually anyway. So I'll put the 2 screws in up top here after making sure this is thoroughly closed. I ended up putting the power leads on the right side, so the cable bulkheads for the high current DC are on the back side here, and they're vertically right above the AC power. So you've got AC and you've got DC right above, and those are set such that it's using this dead space behind the variac. So now I've got all this space over here I can use. Maybe I shove more capacitors in here, but that's, you know, for future expansion use or additional add-ons. So there we go. It's the power supply, and I'll go ahead and screw it shut and add some more labels to it, but it's basically there. Okay, so what I have here is a variac with a DC power supply that is very useful for me hooking up to oven transformers or random oil burner transformers or neon sign transformers. So the AC output there is obviously a 20 amp, and then I've got 100 amp of rectifications. These are 250 amp rectifiers set up here, you saw earlier in the video, and I've got these two bulkheads. I've got them hooked to this industrial resistor just to give an example of what this thing can do and how it doesn't even care. So I want to flip on the DC load bank first, or the DC tank circuit. And my load bank is one resistor. So anyhow, DC tank circuit's on. This shows the voltage directly off the caps like I showed you earlier. So we're going to make sure we're at 0 on the variac. I'm going to turn it off, and I'm going to quickly ramp up. You can watch, this will be current draw AC into the variac, voltage output from the variac. Actually, that's amp output from the variac. So that's all the current going out of the variac. Either way, current coming out of the variac, volts coming out of the variac, and this is going to be tank voltage on the DC side. I don't have a DC amp scale because I didn't care. Anyhow, here she goes. I don't want to do it too long because I don't want to burn up my little resistor, but turn everything back off, make sure we're at 0, and then I'm going to grab the plug. There we go. All right, and de-energized cords here. And you can see this resistor is going to be spicy. It's not super hot. It's pretty warm though. It's about as long as I want to touch it right there. So I don't know what that temperature is, but it's like a glass of hot water. Anyhow, I think it looks pretty cool. Kind of got some little blue caps hanging out there, and then these two rectifiers, they don't even get warm. Like, they're bog cold. There's, like, even if I open this, there's no heat to it. So what I'm going to do, my next step, let me go over here real quick, grab. I've got some contactors. Unfortunately, all the contactors I have are normally open. I don't have any with the attachment on the front for normally closed, like regular, push stop button controls. So I've got a attachment one shipping in, so I can actually have some normal closed. And what's going to happen is that's going to mount in the chassis behind the amp meter. And the normally closed side is going to go to 2 of these resistors, so that whenever you disengage the DC tank, it's going to immediately drop into a resistor, and I'm trying to show you current. It'll immediately drop into the resistor and suck that tank voltage down and just turn it to heat, so that there's no chance of high discharge. For now, I have a label. Yeah, don't even once unplugged, she can be high charge. I can get this thing up to a couple hundred volts, and it will hold it for probably an hour. Really good caps. I mean, it'll hold a lot of voltage in there. It's not a ton of current. It's only 76 joules, but 76 joules at 100 volts even. That's across the heart. If I was to touch this, while the thing was charged, it would be bad. Might have to have damp fingers, but still don't want to have somebody get hurt. So that's the improvement. So right now, understand there is no automatic drain on the tank, but what'll happen in the future is you turn on that DC tank and it'll suck this down as it puts power to the tank circuit, and then while it's running, and then you flip DC tank back off and it'll drop back up. It'll close the circuit to the resistors, and those resistors will drain down the tank. That's the plan anyway. I mean, I guess if you had a second power supply hooked to whatever DC thing you're connected to, then now it's acting as a resistor for that, but in my use, that's not going to be the case. So plan on trying to do some cool, degosser stuff, things like that. I need to get a bigger capacitor bank externally to hook to this, and that'll be a whole nother thing, maybe years down the road. I don't know how much I care, but I wanted to build this for a while. I've had this in my head since a long time. Wanted to make this video a year ago, but I just got distracted. Life has been busy. The other thing that's going to happen is I use this for microwave oven transformers. I didn't have you see my other variac, it's only a 5 amp, so this gives me a much bigger variac that I can have a longer duty cycle on, and I can run at a higher current. And the idea with that is I can do Jacob's ladder or microwave oven transformer stuff, and I plan on building I'll get a second bud box, and it'll have a power cord on it basically, and be designed to set for this, and then it'll have meters on it, and its output will be either 0 to 10K or 0 to 8K, depending on how I set it up and what kind of transformers I end up using, but I'll have a kilovolt display on it. So basically, I want to be able to stack it and just kind of set it on top, like a hi-fi of high voltage, I guess. And like I click this thing on, I can turn that up, and I can actually, have an AC and a DC brick I can attach on top of this. That was the kind of mental vision I was going for. So I don't know. We'll see if I ever get around to it, but sort of the idea here. I hope you enjoy it. See ya. All right, so here's the test setup. We got our power supply. I've got my, what I'm going to call the safing resistor. And then I've got some speaker cord, the highest quality, whatever ancient Best Buy brand I had on the shelf. And a giant length of PEX pipe. And down here on the floor, you're going to see I have a little, disconnected everything. This is a little tiny piece of aluminum wire. So, kind of hard to see, but we're going to see what happens when we touch it. You can see I've already done it a couple times, but I want to catch it on camera. So, this is going to be at about 150 volt DC with that 76 joule cap bank charged up. Not even the max power this thing could put out, but top of the gauge for the DC panel meter I have. I don't want to hurt the panel meter by going over, but it looks like, because obviously it's measuring the peaks of the AC waveform going through the rectifier, so it's higher than the small number. So it's not root mean square calculation, right? But you can see there's a chunk of copper right here, a chunk of aluminum that got blown off. Let's put on I will be wearing the welding hood because the flash is so bright. I don't want to hurt my eyes, but I'll put this down here so you guys can watch on camera because it won't hurt your eyes through camera. That's nice, isn't it?